Hey guys, it's been a long time since I released a new video, but I'm coming back with like this math question that I found from like a YouTube channel called JPy Maths. It's apparently a Cambridge entrance exam test question, so let's go ahead and solve it. The method that he showed in the video, I found it to have a lot of algebraic manipulations. Instead, my approach was slightly different. And anyways, here's the question. It says that you have like three equations that they've given you: x plus y plus z equals 1, x squared plus y squared plus z squared equals 2. Same thing with the cubics. And they want us to show that xy plus yz plus zx equals minus a half. And the summation of xy square plus the summation of x square y is equal to uh, -1, and to also show that xyz equals 1/6. And in the end they want us to show that if Sn equals x power n plus y power n plus z power n, they want us to show that Sn plus 1 equals a Sn plus b Sn minus 1 plus c Sn minus 2. So let's get started. So what you can do is to show the first half, that xy plus yz plus zx equals 1/2, you can just square the first term, which is x plus y plus z equals 1, because it gives you the terms that you require. So just go ahead with the first part, x plus y plus z, the whole square. If you know the identity, it's fine, or else you could just do the multiplication by hand, but I know the identity, so I'm gonna be using it. This is the identity, and we know that x plus y plus z equals 1, so this is just gonna equal 1 square, which is 1. But they've given that this term is equal to 2. So from here it's evident that xy plus yz plus zx, so you can get to know that this, you can take the 2 that side, you get a -1. -1 by 2 is just -1/2. So you got the first part of it. This is quite simple. And they also want us to show that the summation of xy square, meaning xy square plus yz square plus zx square, and summation of x square y, meaning x square y plus y square z plus z square x equals -1. So again, you need to find, like, you need to figure out which two equations do I need to multiply to create the xy terms and the x square y terms. And the answer is, again, it's quite simple. So you just have to multiply x plus y plus z equals 1 and x square plus y square plus z square equals 2, because you can multiply the y with the x square and get a yx square term, and similarly you can multiply an x with a y square and get the xy term. So it's just that simple, and you multiply these both equations. And this is equal to 2 times 1, which is just 2. And now you have to expand this. Upon expansion you get something like x cube plus y cube plus z cube plus xy square plus xz square plus y x square plus yz square plus zx square plus zy square. and all of this is equal to 2. But you know the value of x cubed plus y cubed plus z cubed, that's just equal to 3. So what you have is 3 plus, and all of these terms like xy square and yz square and zx square all come under summation of xy square, and the rest come under the summation of x square y, right? So summation of xy square plus summation of x square y is equal to 2, and from here you get summation xy square plus summation x square y is equal to -1. Yep, this part was also quite simple. You can probably look into the question a little bit more because I'll be flipping the page now. And again, now we want to find out, we need to prove that xyz equals 1/6. So how we would approach this is, we again need to figure out what two equations we need to multiply in order to get the xyz terms. If you look very carefully at this equation, we have xy, yz and zx, and each one of these are missing one term. In xy you're missing the z, and yz you're missing the x. So if you just multiply this by your first equation xyz, you're gonna get the missing terms and you'll be getting xyz terms. So let's go ahead and do that. So now you'll be multiplying your xy plus yz plus zx with your x plus y plus z, and this is just -1/2 times 1, but I won't be writing the times 1. Now if you expand this, you get x square y plus x y square plus xyz plus xyz plus y square z plus yz square plus x square z plus xyz plus z square x. All of this equals -1/2. And if you rearrange all of these terms very nicely, what you'll be getting is x square y plus y square z plus z square x plus, I'll be writing this in a bracket, and xy square plus yz square plus zx square in another bracket plus 3xyz. This is the term that you've been trying to find, right? And all of this equals -1/2. And from the previous results, we already have the value of summation xy square plus summation x square y, and it's equal to like -1, right? So we have the value for this. So summation of x square y plus summation of xy square plus 3 xyz equals -1/2, but this is equal to -1. So you can take the -1 to the other side, it's gonna become a +1. +1 -1/2 is just 1/2. So you have xyz equals 1/2 divided by 3, so you have 1/6. Now coming to the last part of the question. Up until now everything was quite easy, right? So now we have to prove that let Sn just read it yourself. You have to show that Sn plus 1 equals a Sn plus b Sn minus 1 plus c Sn minus 2. So right now, the method that I thought of was like this. Instead of directly going and proving or trying to figure out whatever they asked us to do, let us take a little bit of a detour and find out what x fourth plus y fourth plus z to the power 4 is equal to. So let's just figure this out. And why we're doing this, you'll get to know in a second. So how do I create these terms that I have over here? If you observe quite carefully, by multiplying the third equation, meaning x cubed plus y cubed plus z cubed, with the first equation, you're essentially gonna create like x power 4 terms, right? So that's exactly what we'll be doing. So x plus y plus z times and another reason why I thought of this is, in the back of my mind I had something like, oh, we can see like a cool little pattern over here. The first equation has powers of 1 and it gives you 1, and powers of 2 gives you 2, powers of 3 gives you 3. So I thought maybe, just maybe, we could have like a pattern going on. So when I solved it by myself previously, that was what was going on in my mind, but you'll get to know what happens. So by expanding this, you'll be getting x power 4 plus y power 4 plus z power 4 plus xy cube plus xz cube plus yx cube plus yz cube plus zx cube plus zy cube. And if you group all of these terms nicely, you're gonna be getting x power 4 plus y power 4 plus z power 4 plus summation. Again, you can take terms like xy cube and yz cube and zx cube together. These all come under summation of xy cube plus summation x cube y, and all of this equals 1 times 3. So this is going to give you 3. So from this, now we have this equation, but how do we proceed? And we can actually use the results that we got previously to figure out how to proceed. If you look at these terms carefully and the previous results that we got, like xy squared plus and all of these, let's see what we can do about it. So here's what I'm gonna be doing. Let's just forget about these terms for now, and let's only manipulate these two terms. So I hope you guys don't get confused between like the summation notation, because it's a nice habit to work with them. So you can take, from what I can see, I would take xy common from both of these. So you basically have summation xy times x square plus y square. So this is what you get, right? And so what this essentially means is, let us just I'll be explaining it in much more detail. So this is essentially you're going to be getting terms like xy times x squared plus y squared plus yz times y squared plus z squared plus zx times x squared plus z squared. So basically, and if you notice this, you have x squared plus y squared, and from this page that you know that x squared plus y squared is basically 2 minus z squared, like if you subtract z squared on both sides, right? So that is essentially what we'll be doing right now. So you have xy times 2 minus z squared plus yz 2 minus x squared plus zx 2 minus y squared, right? So if you expand this, you basically get 2xy. I'll be rearranging it and expanding it at the same time. Plus 2yz plus 2zx, and you have minus xyz squared plus minus xy squared z minus x squared yz. I hope this is clear. And if you notice this, you can take a 2 common from all of these terms, and you'll be left with 2 times xy plus yz plus zx. And guess what? You already know what this is. This is just equal to minus a half. So like these terms simplify to 2 times minus a half and minus, you can take xyz common in all of these 3 terms, right? Minus xyz times x plus y plus z, right? So this simplifies to minus 1 minus, and we know xyz, we know that xyz is 1/6, so minus 1 by 6, and we know xy plus x plus y plus z is just 1. So this is what we have, and guess what? This is not your final result. This is just equal to summation of xy cube plus summation x cube y, right? So now we plug this back into this equation, and we get x power 4 plus y power 4 plus z power 4 plus, what is minus 1 minus 1/6? Minus 1 minus 1/6 essentially gives you my bad, this is supposed to be, so this gives you minus 7 by 6 plus minus 7 by 6 is equal to 3, and 3 can just be written as 18 upon 6. And now you take your minus 7 by 6 to the other side, and you get x power 4 plus y power 4 plus z power 4 is equal to 25 upon 6. And this is not as we expected. We saw a little pattern going on, and we expected this to be equal to 4, but it's actually just a little off, but doesn't change the fact that this is your correct result. And now we have everything that we required to find out the answer for the last part of this. So in order to find A, B and C, which are your 3 unknowns, right, we need 3 equations. And that is precisely why we even found out what x power fourth plus y power fourth plus z power fourth is equal to. And now if we write down everything that we know that summation of fourth, s4, like all the fourth degree terms, is equal to 25 upon 6. And summation of all of your third degree terms is equal to 3. Summation of all of your 2 degree terms is equal to 2. Summation of all of your 1 degree terms, which is s1, is equal to 1. And summation of all of your 0 degree terms. What about your 0 degree terms? Again, you'll get to know why we're doing this in a second, but such that the relation is satisfied so is satisfied, I forgot to write down the entire question, my bad, is satisfied for all n. So the word all n is very important, right? It means that n can even be negatives and 0. So s of 0 is essentially, let's just find out what summation of all of the 0th terms are. I'll be making like a small box over here and we can find it out in this. So summation of all 0th powered terms is just x power 0 plus y power 0 plus z power 0, which is 1 plus 1 plus 1, which is equal to 3. So this gives you 3. And what about s minus 1? Again, you'll get to know why we're doing this in a second. So this is basically 1 over x plus 1 over y plus 1 over z. And if you take LCM, you'll be getting xy plus yz plus zx divided by xyz, right? And we know that this is minus a half and xyz is just 1 by 6th. So this gives you minus 3 is minus 3. So using all of these results, we can come up with 4 equations. So if you look at this is how our 4 equations are gonna look like. S4 is equal to 25 upon 6 is equal to a times S3, which is a times 3 plus b times 2 plus c, and S3 is equal to 3 is equal to a times 2 plus b times 1 plus c times 3, and S2 is equal to 2, which is equal to a times 1 plus b times 3 plus c times of minus 1. C times of minus 3. So these are the 3 equations. I'll be writing them down in the next page too, but all we have to do is solve for them. And now the trick to solving 3 equations with 3 unknowns is, first eliminate any third variable by taking 2 equations at a time and get it in terms of 2 variables and solve those 2 variables with 2 equations, and like that you can just figure out the third equation. I'll be demonstrating it. So if I were to just add the second and third equation, let me just name them. Right, if I just add the second and third, what I'll be getting is 3a plus 4b. The 3c and the minus 3c cancel, equals 5. So this is one equation. And another equation, I can just multiply the first equation by probably so I'm thinking of what two equations I should be solving for, right? So what I'm thinking is, how about we consider these two equations. So I multiply the first equation by 6 and I'll be creating a 6c term, and I'll be multiplying the second term with a 2, which also creates a 6c term. So if I multiply the first equation by 6, what I'll be getting is 18a plus 12b plus 6c equals 25. And I want to subtract this from your second equation, which is multiplied by 2. You get 4a plus 2b plus 6c equals 6. Right, now I just subtract them. When I subtract, these both get cancelled, so I get 18a minus 4a, which gives me 14a plus 10b gives me 19. And now you have two equations and two unknowns. So how I'll be solving this is, again, I can see that I have a 4 and a 10. So I can multiply the first equation by 2.5, which gives me a 10b term. And this equation just times 1. So when I solve it, I get 2.5 times 3. I can write it 2.5 as 5 by 2. So I get 15 by 2a plus 10b equals 12.5, and 14a plus 10b is equal to 19. So solving this is basic. 14 can be written as 28 by 2. You get 28, so you get something like minus 13 by 2a. These both cancel, is equal to minus 6.5, and minus 6.5 is basically minus 13 by 2. So you have your a is equal to 1, and you can substitute a is equal to 1 in this, and you get that a is that your 4b is basically equal to 2, so b is equal to 1/2. And since you know a and b, you can substitute it into like one of these three equations and figure out c. And c gives you a, b, so you're gonna be getting 1 plus 3 by 2 minus 3c is equal to 2. So this gives me 2.5, so minus 3c is equal to minus a half. So this implies that c is equal to 1/6. So therefore Sn plus 1 is equal to a times Sn plus b times Sn minus 1 plus c, which is 1/6, plus 1/6 times Sn minus 2. And that is your result. Thank you.